the elementary school. So here is Lori.
Thank you. Can you hear me there? All right, let's get started. I'm Lori Williams, and I am not a soil expert by any means, but I have a huge interest in trying to grow and eat the healthiest plants and put the healthiest stuff into my body. So, how many of you have ever told your kids or your spouse, eat your greens? They're good for you. Yeah. Well, here are 2 heads of lettuce, but there could be a world of difference, even though they look the same. So let's look at that first one on the left. It could be sprayed with pesticides to kill those bugs, herbicides to kill the weeds. And maybe it's irrigated with trenches that are runoff from a nearby, close to a nearby cow pasture. And maybe that cow pasture manure might have some bad pathogens or E. coli, and you've all heard of the lettuce and the romaine especially, that gets recalled because of E. coli. Does that look really appetizing to eat? All right, let's look at the one on the right. So imagine this one grown in organic soil full of nutrients and vitamins and minerals. It's healthy. It's naturally resistant to diseases. And when we eat this, all those great nutrients go into making our bodies naturally healthy and strong. Does that one look pretty good to eat? Yeah. So our health doesn't depend on just eating vegetables, but it depends on the quality of the plants that we eat, or eat those plants and we eat the animals or their products. We want to make sure that the plants are strong, and for great plant health, it's all about the soil. And that's our theme for today. So let's get started. And I love January because January, the stores are starting to get their seeds. I've gone through the catalogs, purchased my seeds, sorted them. I've been planning out my garden, and I'm just dreaming about juicy tomatoes and crunchy cucumbers, fresh salads. And I'm ready to start growing my seeds. I think I'm missing one, but seeds. Next one. So I'm missing one, but it's not always as easy to grow seeds as we think. And I'm kind of a new gardener. And so my first years, I would plant my seeds. I was so excited, and I'd give them all sorts of happy thoughts, grow, grow, grow. And I often grew weeds or large broccoli leaves and not broccoli. And after a while, I started to realize that it's the soil. So now I run to the store and then I get really confused because I see bags and bags of potting soil, compost, garden soil, potting mix, transplanting mix, seed starting mix. How many of you have experienced that? And then you've got all sorts of fertilizers, mycorrhizal fertilizers. You've got your cocoa coir, you've got your peat, you've got your blood meal, bone meal. And I'm usually so overwhelmed by the choices that I shake my head and just leave. Has it always been this way? It hasn't always been this way. And we've often had so many, not only things to purchase, but so many recipes that we can do. In the past, let me see if I can use this better. Before the 1960s, we just walked outside and we used the soil that was outside, and we crossed our fingers that we had good loamy soil. And if we needed to enrich our soil, the go-to back then was to find some manure and add it. But in the 1950s and 60s, peat started to be used and digging up the peat bogs. And chemical fertilizers started to become really common after World War II. And then if we wanted to start seeds inside, we'd often just dig up some soil off outside, bring it in, use a windowsill with a lot of good light and cross our fingers. And so today, when we hear about soil, it could refer to a lot of things and get really confusing. So natural soil, garden soil, has a lot of living organisms in it. And often that's your sand, silt, and clay with a lot of that humus and organic matter. And that's our good natural soil. But when people start talking about soil, often it's a huge umbrella. And under that umbrella are amendments or additives to the soil, which are usually anything that improves the soil. And I know there are differences between conditioners, amendments, additives, fertilizers, but for today, I'm just going to put these under the umbrella of amendments. Now, all of these things that are brought in from the outside are going to have some degree of environmental footprints.
What?
And that's why gardening has a lot of choices. It's up to you whether you use any of these at all. So the ingredients of healthy soil that we've heard from our past two speakers, we have all this inorganic material, your mineral, sand, silt, and clay that makes up about 45% of good soil, your organic matter about 5%, and most of our soils don't have enough of that organic material, but we still need 25% water, 25% of air. And it's because your organic matter and your sand, silt, and clay, they support the plant. They're going to support those roots. And those nutrients are provided by your organic matter. If it's out of balance, you're going to have too much water in there. If it's out of balance, you're not going to have enough air for the plants, the roots, and for all those living things in the soil. Now, why don't we just bring in that outside soil to germinate our seeds for our indoor potted plants? And it's because outdoor garden soil is alive. It's teeming with plant matter in all stages of decay, tons of microorganisms, weed seeds, bugs, a lot more. It really is alive. And it's up to you. Is this the medium you want to use for growing seeds, to bring in for your house plants? It's your choice. But do you want your house plants in soil that might have weed seeds, bad pathogens, insect eggs like fungus gnats, mites, aphids that are just getting ready to hatch in your house? So are there better alternatives with less living organisms that might help your germination rate? Soil that's less alive. So for the organic part, that 5% part, one of the main alternatives is sphagnum peat moss, and it can take the place of your organic matter from outside. It's lightweight. It will retain 20 times its weight in moisture and water and releases it slowly. It's essentially free of pathogens because of where it's been grown. Free of bugs, weeds. It holds very little nutrients, so it's close to sterile. But the disadvantages, it tends to be acidic, which is why often people will add some lime to raise, so it's not quite as acidic, to raise the pH. And then with peat moss, you have the environmental concerns. So peatlands are really unique ecosystems. They support a ton of biodiversity, and they serve as carbon sinks. And when harvested, that peat releases lots of carbon dioxide. And it grows really slowly, about 1 millimeter a year. So some countries have banned the use of peat moss. because they've used most of their peat bogs. It's not sustainable. The peat available in the US comes largely from Canada. And the peat bogs cover about 13% of Canada. So if you use Canadian horticulture peat, it's managed by 3 organizations, and they try to focus on responsible management, sustainable harvesting, and restoring their peat lands so that they're supposedly growing peat as quickly as it's being harvested. And peat's going to be used in a lot of these products that you're going to see, but it's your choice whether to use it or not. And because of the unsustainability of peat, and the sphagnum peat moss is the upper living layer, and then after years and years and years, you've got the traditional peat, that's the deeper layers. But because of the environmental impact, a lot of people are turning now to coco coir as an alternative to peat. And it's because coconuts are renewable. They're in huge supply. And coir is lightweight. It absorbs about 7 to 10 times its weight. It has really good drainage, is pH neutral, so you don't have to add the lime, and is sterile. There are disadvantages, however. The coconut palm tree absorbs salt water. So coco coir has varying degrees of salt content, which may not be the most conducive for growing seeds. So you might need to rinse it. Producers nowadays are doing a much better job of rinsing that coir to reduce that salinity. So depending on the quality of the coir that you buy, you might not have that salinity problem at all. Environmentally, most tropical areas growing coconuts are in countries with fresh water scarcity. So it takes a ton of water to separate the core from the shells and to reduce that salinity. And then it needs to be transported around the world. So there is an environmental footprint for core as well. So peat moss and core, they both provide more sterile environments. They provide that structure for the plants. They improve water retention, but both can hold too much water and they can get compacted. So now it's important to get the airiness into your organic matter. So we've got sand and clay in nature. Why not just add sand or add clay? Well, sand has large particles, water can drain too quickly, and sand is heavy. So imagine picking up that bag of sand. Clay particles are so fine, they stick together, so the roots have a hard time breaking through them, and they hold too much water. And clay is also super heavy. So for these inorganic minerals, the alternatives, perlite and vermiculite. Perlite takes more of the place of your sand, and vermiculite more of the place of your clay. So perlite, it's a mineral from volcanic glass. It's superheated until it pops like popcorn. It's really lightweight. It's sterile. It provides spaces to aerate the soil. And it's excellent medium for your indoor seed starting, when seedlings are prone to damping off and root rot, and propagating cuttings. So I propagate some cuttings directly into perlite. And it's great for your indoor and outdoor containers that need that drainage and that aeration. And then vermiculite is also a mineral that's superheated until it pops. It's sterile, it aerates the soil, and it retains water really well. So it's also used for seed starting, indoor and outdoor containers, and even outdoor gardens. So both perlite and vermiculite are expanded volcanic rock, very light, very airy. The main difference is perlite doesn't retain water very well. So that's why it's added to a lot of cactus and succulent mixes, because you don't want all that moisture in the soil. Vermiculite surface is more porous and retains more water. So it's great for plants that need more moisture in the soil, like ferns and lilies. So both are good for indoor and outdoor containers, seed starting, but because both are mined from finite resources, processed at high heat and transported, there are environmental footprints for these also. So today we're going to take a look at some of these most common soil amendments and products and see how they're used for seed starting, transplanting, indoor plants, and then your outdoor garden beds. And let's start with seed germination. So seeds are amazing. Inside each seed are fats, fibers, vitamins, minerals, micronutrients, proteins, and more. And some are edible, which is why they're so nutritious for us to eat. They need air, water, warmth, but they do not need nutrients or fertilizers in the soil to germinate. They have everything they need to start that germination process. Oops. Some seeds, like the dandelion, can grow on really poor soil. They can grow on compacted soil like clay and even dirt. But most of your vegetables are very tender and delicate, and they're going to do best in sterile seed starting mixes. So young seedlings don't yet have those defenses to fight off pathogens or bugs that might be attracted to them and start nibbling on their roots. And because diseases like damping off and root rot spreads easily through your soil mixes, we take care to provide a sterile environment whenever we're germinating seeds. And it's also important to use fresh seed starting mix for new seeds if we want the best chance of germinating. If you don't care and want to just experiment, then yeah, bring in your garden soil and compare. So this one seed starting mix has only sphagnum, peat moss, and perlite. The peat moss to retain that water, and the perlite to add aeration and to provide water drainage. There's no fertilizer added because the seed is all it needs to germinate. Now let's start taking a look at some products you can get on the market. Here are two different seed starting mixes. So the first has mainly peat, vermiculite, and a little lime because it needs to raise the pH because of the peat. And then on the one on the right, it contains peat moss, perlite, and vermiculite. It adds the vermiculite to just make sure there's moisture in the soil. Now let's look at this one. This seed starting mix has two ingredients instead of peat, coco coir, and 30% perlite. So in most of these seed starting mixes, you're going to see about half coco coir or peat, and then up to 25% probably of your perlite or vermiculite. Store products versus do-it-yourself mixes. If you only have a few to germinate, the benefits for buying from a store, it's ready to use. It's easy. They're sterile for your indoor seed germination and your plants. A disadvantage, they're more expensive. And the company is in control of the ingredients and the percentage of the mixes. The do-it-yourself, if you're going to be germinating a lot of seeds, if you've got a lot of indoor containers, outdoor containers that need to be lighter, airier, better drainage, it's less expensive for you to buy bulk peat, coco coir, vermiculite, perlite, make your own blends and mixes. And that will save you money and you get to control the ingredients. The great thing about do-it-yourself, there's no one right recipe for a mix. Here's a whole bunch of recipes I saw online. You don't even need to be that precise. And for seed starting, you don't need any nutrients, fertilizers in the soil. because that seed has everything it needs to germinate. So in general, like the first one, 2 parts peat or 50% peat or 50% coco coir, and then 25% perlite. Vermiculite is a very common mix, or some will substitute coco coir, or some will just mix up peat and coco coir. So it's up to you what kind of mix you want. Some will substitute sand instead of perlite. Some will use some ground wood products. Some will use peat, perlite, and then once the seed's planted, sprinkle vermiculite on the top, because then the seed can easily push through that light vermiculite. And if the vermiculite is on top of the soil, the fungus gnats have a hard time laying their eggs and finding soil. So there are all sorts of ways people will try to use this sterile potting soil inside the house, because you don't have the ladybugs and natural predators in your house to be able to eat these aphids and mites. So that's why they prefer something sterile, which will help to reduce that. Here's another seed starting mix. So you see sphagnum peat moss, coco coir, perlite. But now take a look at the seed starting mix. They've added some fertilizer and some mycorrhizae fungi. And mycorrhizae fungi has been shown to increase some plant vigor, resistance to some diseases, better responses to stress. But why add those to seed starting mix if seeds have all the nutrients they need to germinate? Well, these first leaves that come out are the cotyledons, and they're part of the seed embryo. They've emerged and they're still being fed by the seed. So you still don't need that fertilizer in the soil. But now you've got the true leaves coming out. Once the true leaves emerge, photosynthesis begins. All the nutrients in the seed have been used up, and photosynthesis requires nutrients for the plant and the roots to grow strong and healthy. And this is when it's time to be adding fertilizers, organic, synthetic, whatever you're going to be using, diluted at first, or to transplant into a larger pot that has a mix with nutrients. So sometimes they add this fertilizer in, because if it's like me, I might not quickly, once the true leaves come in, transplant them into a larger pot with some nutrients. It buys a little bit of time, so that it might get 1, 2, 3, 4 sets of true leaves and still be doing okay. And here's a transplant mix you can buy. Another mix. It's got to be something very special. Let's look at the ingredients. Sphagnum peat moss, perlite, coir, lime to raise the pH, the mycorrhiza, and the wetting agent. And wetting agent is that peat and coco coir have a tendency to dry out and got compacted. So sometimes when you water, and that water just goes right down the side of the pot, it's because it's pulled together. The wetting agent just keeps it fluffier, and these might be synthetic wetting agents or organic, like the yucca plant. But notice the base ingredients tend to be the same. So do we need the transplant mix? It looks the same as the seed starting mix. When we transplant them, now there's potting soil. Now there's potting mix. What in the world is the difference between these two? So let's look at potting soil. Main ingredients: peat moss, perlite, they put some sand in, nutrients, potting mix, same thing. It's got mainly your perlite, your aged forest products, and then it has some organic nutrients, and it's mostly the sphagnum peat moss. So it's very, very similar. Both have some added organic nutrients. The organic nutrients, earthworm castings, alfalfa meal, kelp, compost, forest products, and some fungi. Now, this potting mix on the left has coco-coir, pumice, which is going to be another type of a lightweight rock, perlite, the nutrient worm castings, and the one on the right, the potting mix, sphagnum peat moss, perlite, composted bark, and then plant food. So let's take a look at potting soil mix versus a seed starter from one company. Do you see some similarities? Peat moss, perlite, vermiculite in both. So companies have ways of marketing and making us think, we've got to buy different products for every single stage. The main difference between a seed starting mix and potting soil mix is a seed starting mix might be really fine and fluffy. So if you take a look on the left, potting soil mix, you've seen I've removed some of this woodier, larger wood chunks. Now, some gardeners will say, my seeds the roots will be able to push their way through it. Others might take the potting mix and sift it because they want it really fine and fluffy. It's up to you. So if you think about seed starting mix, potting soil, potting mix, transplant mix, think of the 4 most common ingredients. What are they? Perlite, coco-coir, peat moss, vermiculite. Perlite, yeah, there you go. There are some alternatives on the market. So alternatives to peat and coco-coir, some might say bark, sawdust, rice hulls. You're going to see a lot of products to make water retention and still have be fluffy. Inorganic alternatives to your sand, clay, perlite, vermiculite, pumice, clay pebbles, sand, horticulture grit. So there are different choices, and it's up to you what you want to use. Now, just about sterile. Really, there is no such thing as soil being completely sterile. There are going to be microorganisms, bacteria, in just about everything. So when we say sterile for indoors, it means that you've got fewer living organisms. Non-sterile outdoors, you've got lots of living organisms, bacteria, fungi, bugs, insects. So all these ones on the left tend to be more sterile. As soon as you open the bag, yeah, it's going to be exposed to a lot of microorganisms. We don't have to be concerned about that. Non-sterile is more of your outdoor garden soil, your bagged garden soil outdoors. And then take a look down below under sterile, you have forest products and compost, non-sterile forest products and compost. And so you may see some bagged things that have forest products or compost. Chances are it was sterilized by heat or by some process. And if you're buying it in the bag and you see that compost, they probably have heated it or made it sterile versus my cold composting at home probably has a lot of living organisms in that, and I might not bring that inside my home. Now, let's go to outdoor soil, and this is where things get really exciting. So to grow nutrient-rich fruits and vegetables, we need nutrient-rich soil. And most soil has low organic matter and isn't perfect. So let's look at how we can improve our outdoor soil mix. Too much sand, it won't retain water. We don't want to add clay directly because sand plus clay makes a cement mix. So the solution, add compost, add organic matter. Let's look if you have too much clay, too wet, too compact. We don't want to just add sand to clay because it'll make cement. The solution to getting a better structure in your clay-like soil, add compost, add organic matter. Not enough nutrients in your soil. We just had the composting workshop. solution, add compost, add organic matter. So there's kind of a theme when you go to your outdoor gardens. But there are products you can buy. You can buy your compost mixes, you can buy your garden soil mixes, or we can compost our own. When I go to the store or when I go to a landscape company and get it by the truck full because it's less expensive, and I ask them, what's the ingredients in your garden compost or your garden mix? Usually it's going to be a combination of your forest products, your wood chips, peat moss, compost, manure, sand, organic matter. And so it's important to ask to find out what's in it. What are the benefits of doing your own compost? You know what your ingredients are. And if you use a wide variety of products, you get a wide variety of microbes in your soil. You get healthier soil. If you compost, just as Bob mentioned to us, you know if there's fertilizer, pesticides, herbicides, if the manure, what the quality of that manure is, was it high composted? You know what's in your compost and the percentage of your ingredients. So let's look at some bag compost. They tend to be more expensive, more limited ingredients. Garden compost. Compost, softwood bark, peat moss. The middle one, organic manure, sulfur, beneficial microbes, and I think it had a base also of some of your peat. Composted cow manure blend. Manure, sphagnum peat moss, aged bark. So they're limited ingredients, and often you can make your own at home. That's going to be much more biodiverse. Here's some garden soil, not the compost. So on the left, it's got one or more of peat moss, forest bark, compost, and plant food. Up at the top, compost, plant food. Forest products, chicken manure, lime. Over here, loam, sand, compost manure, peat moss. Do you see a pattern there also? Yes.
So I see forest products mentioned a lot. Is that like shredded trees or what is that?
Often it can be, and I would encourage you to Google Dr. Linda Chalker Scott, a professor at WSU, and she is the expert in amendments in soil. Chalker is spelled C-H-A-L-K-E-R. She will put down on her beds and even her vegetable beds, arbor chips, forest products, right from the branches. It has all the living needles. It's what falls to the forest floor. And that is her fertilizer, her organic fertilizer. It takes the place of a lot of these products. So there are a lot of choices out there. The forest products are different than the bark. Bark tends to be a little more waxy and it could repel some water. So do a deep dive into these forest products. It becomes quite interesting. So now topsoil. This is really interesting too, because you have your rich, loamy soil that's been formed for hundreds and thousands of years, sand, silt, and clay, and organic matter constantly decaying. But because we've done so much tilling and industrial farming, we've used up about half of our topsoil around the world in the last 150 years. So when you hear topsoil, you might be thinking that ultra rich soil. Topsoil also can be filtered with very little living organism, good to fill the holes in your garden. So have to check that out as well. So now organic matter, organic fertilizers versus synthetic fertilizers. First thing that comes into mind, NPK. Nitrogen, grow up. Phosphorus, grow down to the roots. Or potassium, down. phosphorus down, potassium, grow all around. And so here's a little picture of some synthetic fertilizer, my little attempt. NPK, if it's close to those roots, it will be absorbed up with the water. But if it's not close to the roots, I think of a slip and slide. When it's watered, boom, it's going to be washed away into our lakes and streams, rivers, and that could cause some more problems with the environment. Now, if we do the NPK, mainly, our plants are going to look great. But take a look at the major nutrients, micronutrients that plants need. They need all of this for efficient photosynthesis so that the plant can make the proteins, carbs, sugars, vitamins, everything it needs for a strong immune system, to be rich in nutrients, to deter pests naturally. And it needs all of them, not just the nitrogen, phosphorus, potassium. And when the plants are dense, and take a look at what we're eating, now we're putting into our body those proteins, amino acids, vitamins, enzymes, minerals for our muscles, our brain, our hair, skin, to build a healthy immune system. And if we use any animal products, we want animals eating plants that are the healthiest and strongest, because that's going to help get us even better nutrients in our body. So how do plants get the best nutrients from the soil? Now we have all those bacteria and fungus and microbes that both of our previous speakers talked about. And these not only include the microbes, but the worms, insects, etc. So everyone take a little pinch of soil. In this soil are 1 billion microbes, billions of organisms. And that's what we need to keep healthy. Plants can't absorb, let's say this is some organic matter. I can't get it into my plant body. It can't do it. But your decomposers, your worms, your bacteria, your fungi, it's going to take this big chunk of organic matter and it's going to break it down, and that then becomes food for other billions of microbes, and it becomes a way that the plant can use in the soil. So this is my little attempt. It's very, very general. Microbes have chemicals that break all of that organic matter, which is their food, into smaller pieces, and they combine with other atoms for the plant's roots to absorb and for other microbes to eat. So let's take a look at synthetic fertilizers. Synthetic fertilizers might already be these little yellow, already broken down. Yeah, the plant root can absorb it, but they're not feeding all of these microbes in the soil that are breaking things down for the plants to use. And what happens then, if all these microbes are not getting fed, they're going to suffer. So there's a symbiotic relationship between plants and your microbial soil life. Which is like this huge living chemical factory that ensures the plants have all their nutrients, but the microbes can't survive without plant hosts and organic matter, because they need the space, the oxygen, the proteins, the carbs that the plant roots and organic matter then provide. So without those plants or cover crops or compost or arbor chips, organic matter in the soil, the microbes and the soil life don't have the food, and the living chemical factory will stop. So depending on the synthetical chemicals that you use, mainly they're not feeding the microbes, so you're going to be damaging the bacteria, fungi, soil life. Here's a nice field of weeds. Weeds can grow anywhere. And they mainly grow when there's very little bacteria and fungi in the soil. And then we usually need more herbicides to kill them off and to feed the plants. And so we're putting more chemicals into our ground. Look at this forest. And this is what Bob referred to. Forests are filled with not only bacteria, but tons of fungi. And the more fungi you have, the less weeds. Do you see weeds in the forest? But you get dense, you get plants, diverse plants, strong immune systems. They can tend to feed off the pests and disease unless they get stressed like our climate heat domes. And so if organic matter is essential for healthy soil, what are the organic fertilizers we might use to amend our soil? Probably the best, earthworms. Because they've got billions of microbes and bacteria in their body, breaking everything down for the plants to use. So worm poop, worm castings are great. Here's some other things that people would use to amend their soil that's more organic. And the key is they're not feeding the plant directly. They're feeding the soil microbes that break everything down in a form the plants can use. So they feed the soil that feeds the plants. And then there are more amendments. One of the things, however, is to use them wisely. Do your research, do your soil testing, because too much of one might be not good for all the organisms living there. So a quick example, I was so excited when I made my first batch of cookies when I was growing up, and my parents took a bite of it and their faces were horrible. It devastated me. And I didn't realize that 1/4 teaspoon of salt was different than 1/4 cup of salt. So adding too much of something may not be a good thing. And again, Linda Chalker Scott, she doesn't worry about all those amendments. She uses the arbor chips, compost arbor chips. So if synthetic chemicals and water soluble can get washed away easily, what's the difference about organic matter? Organic matter possesses these charged surfaces that can hold on to nutrients. So peat, cocoa coir, they don't have nutrients themselves. And I was going to bring a balloon, but I couldn't get it to stick to my hair this morning because it was up. But imagine I'm peat moss or organic matter. I rub a balloon and it sticks to my head. That's your electrical charge, that it sticks. So they're valuable. They can hold the nutrient, the balloon nutrient. And these are the nutrients that they'll hold. Your clay, your vermiculite, they hold nutrients. The same thing. Perlite, it's great for aeration, drainage, but if I rub that balloon on perlite, boom, it's just gonna fall off. It won't hold those nutrients. That's why people don't use perlite much in their outdoor gardens, because it's light, it's gonna float to the top, wash away, doesn't hold nutrients. It's better in your containers and in your seed starting. So in summary, indoor plants, germination, light, airy, more sterile mixes, but it's your choice. Outdoor garden beds, now is the time to feed all the microorganisms in your soil, breaking down everything to feed your plants. Fertilizers, in a nutshell, synthetic fertilizers fast feeds the plant, but it can damage microbial life. Organic fertilizers, compost, nutrients, slow feeds the soil life mainly. There are so many choices. So now let's take a look at this lettuce. Which one do you want to be feeding yourself and your family? Nutrient-rich soil. So in order to get our best nutrients, we need to eat nutrient-healthy plants. And that takes nutrient-rich soil, which means we've got to have healthy microbes, bacteria, fungi in our soil. That's what we have to feed. So now you have your spouse or your kids eat your vegetables. We can now change this saying to eat your veggies grown in organic rich soil alive with organisms feeding the plants complete nutrients for their health and your health.
Yes.
It's all about the soil. Thank you.
Are there any questions? No. Were there any,
Okay,
There's a couple on Zoom. The first one was, what is the difference between compost and mulch in a raised bed garden?
and compost is all the broken down organic matter that you're putting in your soil. Sometimes you mix it into just the very top. Mulch is only on top. So the mulch is going to help you retain the moisture. It will be breaking down. It will be becoming your compost. But it's great to help keep out the weeds, retain the moisture. Linda Chalker Scott, she uses the arbor chips as mulch. She does not rake them in because then, as Bob said, then you've got a little bit of your nitrogen zapping action. But just use it on top. It'll eventually, nature and the microbes will break it down. You'll get rich compost eventually. So that's the main difference.
The next one is, how long will potting mix last? Is it okay to reuse old potting mix from annuals? And then best way to refresh the potting soil, and can you use green homemade compost in there? So that was a lot. I can repeat it.
Yeah, if you trust your homemade compost, try it and see how many little bugs you get going. If it's outdoors, you've got plenty of natural little predators. How often you need to repot? Some people will say every year. Some people will say don't reuse it, use something more sterile. Others will say use it, just refresh it with some, compost that's more sterile, or add your fertilizers, etc. So there are no hard, fast rules of this is what you must do. It's all up to you.
And then the last one, was a comment between this presentation and Bob's. They said Lori's comment about adding compost for nutrients is in contrast to the former speaker, Bob, who said compost is not a fertilizer. Am I misunderstanding?
Compost, so fertilizers often, and it's the term, often like your NPK, your synthetic fertilizers, and they're organic and synthetic, will generally be taken up by the plant roots. Your compost is really feeding your soil organisms that break things down into the form of NPK that the plant can use. So for example, 75% of this air around us and in the soil is nitrogen. Nitrogen is 2 nitrogen atoms, triple bonded. The plant can't use them. It can't get in. But once in the soil, your microbes break them apart. And they combine with other elements that the plant can use. So your compost is feeding all of those microorganisms. So what bob was saying also is the same type of thing.
all right, thank you. Well, thank you all.